Welcome back to another Patreon episode, and in this episode I want to look at adding an advanced enemy AI. So let's get started. So to start with, we've got a very basic scene created. I've actually downloaded this project and I'll put it in the Patreon description as well. So if you want to follow along with my example, you can, but obviously you also have the finished example given to you today as well. And this basic example has just got a player with some animations, courtesy of OpenGameArt. It's got some rocks, and it's got a bat. And then all I've done for the event sheet is added some code to animate the player, and added in a basic Y sort, which sorts all the sprites. So if the player or the bat moves behind the rocks, then they look like they're behind the rocks, and vice versa if they come in front. But we don't care about our player today. The star of our show is going to be our bat, because we want to add in lots and lots of character to our bat, so it doesn't feel just like an enemy that has a pathfind behavior and that's it. We want it to be able to do lots and lots of interesting different things based on what's happening in the game. So where do we start with this? Well, the first thing I'm going to do is add in our behaviors, because we need a few to get started. And I'm actually going to start by doing something I don't normally do, which is just add loads of them before we've even got to that stage in the video. So we're going to start off with the really simple one today, which is the pathfinding. That should be really obvious why we need pathfinding. The others might not be as obvious. So the next one that we're going to add is actually our line of sight. And we're going to actually add this twice. And we're going to rename both of them. So our first one, line of sight player. So this is checking, have we got line of sight of the player? And our second one is actually going to be our attack range. So we've got two different line of sights. They can be set to two different distances. So one of them basically says, well, the player is only 100 meters away from me. I'm going to walk towards the player. The other one might say that the player is 10 meters in front of me. I can now attack it. So two different sets of rules we've got in place. We're also going to add in the timer behavior. And we're actually going to set this one up twice as well. So the first one is going to be called the stun timer. And this is if the bat gets hit, how long is it stunned for? And our second one is the search for player timer. And simply put, if the player leaves the line of sight, it will actually search for the player for a small amount of time. If it can't find it after that small amount of time, then it will wander back home. And with that, we should have all our behaviors that I think we need so far. Let's move on to our instance variables. And we're going to add just a few to get us started. The first one I'm going to add is health. Nice, simple, and we'll give it 5 because we want our bat to be able to take damage. And we want to be able to kill the bat once it's took so much damage. We also want to record its start X and start Y position. You could also call this home X, home Y. Essentially, if the player is too far away from the bat will return home to where it was to begin with. It will no longer chase or seek out the player. And then probably our most important variable, star of the show today, is going to be state. And this is going to control what the bat is currently doing. Initial value I'm going to keep blank, but we'll change that later on. And with that, we should be set up so far with all the things I think we need to get started. So let's move to our event sheet. So first thing I'm going to do is I am going to create a new group called bat, and all of our bat code will go here. And the first thing I want to set up is our different states. Now, just quickly, in a notepad file, I've set up the different states the bat could be in. I've actually set them up in priority order as well, of which ones I want the bat to do first, based on certain conditions and rules. So the most important thing is dead. That should take priority. If the bat's dead, that is the biggest priority. The bat shouldn't be doing anything else. If the bat's stunned, then it should ignore all of the actions underneath. I've got this one called retreat, and essentially if the bat has only got 1 health left, it will choose to retreat away. And it will prioritize that over attacking the player. It will prioritize that walking towards the player or searching for the player. Then if none of these 3 conditions are met and the condition of the player being in attack range, it will take this one as its main priority. And then if these 4 don't apply, it will then walk towards the player. If obviously the condition is met where it is in range. If it's not in range, it will search for the player if that timer is still running, and then it will wander home, and if it doesn't need to wander home, it will start to roam. So these are the different states that our bat is going to have. So let's start off with the really simple part and putting in all our rules for this code here. So let's start off with a nice simple one. Is the bat dead? So we're just going to go to bat, and we're just going to compare its instance variable, and we're just going to check if health is less than or equal to 0. Now I like to do less than and equal to instead of equal to, because if you've got a game where you can deal more than 1 damage at a time, there's a chance you could skip 0. So less than equal to, slightly better. If it is, we're just going to take our bat and we're going to scroll down and set value, and we're going to set the state to dead. And then we can decide what happens if the bat's in that state. The most obvious one is we're going to play the death animation. We might have some gems come from our bat, but the bat's going to be destroyed. That's the main thing that's going to happen. We're then going to click at the side and add an else statement. Now the reason we're adding else is if we just put all our conditions in a row, the bottom one would take priority, not the top one. Now we could just reflip all of our different conditions, so we start with the least priority at the top, but then the issue we create is having to check every single condition. Why, by adding the else, it will actually just go down the list, and as soon as it finds one, it will skip the rest. So it's slightly more optimal. We'll see that as we get a bit further into our code. So as well as the else, we actually need another condition with this, and this one is going to be on the bat again, because again, he is the star of our show. I'm going to scroll down until we see the stun timer. Now make sure you're on the stun timer and not the search for player timer. Doesn't really matter with the timers, but again, this is just a way to keep your code a bit more organized. And we're just going to check if that timer is running. Now, because we're using 2 separate timers, we don't actually need to worry about tags for this. So I'm just going to leave the tags blank. You could just have one timer and then have different tags for it. I'm going for a slightly different approach today. So if the timer is running, then all we're going to do is take our bat, scroll down, and we're going to set the value of state, and this time to stun. And we repeat the same again. We right click, we add our else. This time we're going to check now about retreating, and we're going to add another condition this time for retreat. And I'm just going to go to my bat, compare instance variables, and we're just going to check if health is equal to 1. Has our bat got 1 health? Well, then it probably wants to retreat. And save myself some time, I'm going to start copying and pasting these statements here, just remembering to change them. So now it's going to retreat. Next, we've got our attack mode. So I'm just going to add another condition to my bat, and we're just going to check, has it got line of sight to object? Remember, line of sight will block against solid, which is what our rocks are, so you could hide behind the rocks as well. But has it got line of sight to the player? If it has, then again, we're going to set our state this time to attack. And we're just going to keep going through this list. Our next one is actually walk towards the player. And we're just going to add another condition to our bat. We're looking for our line of sight. That's really important that we don't use our attack range one, because this is going to be a smaller cone. We want to use our line of sight player, which is a much bigger cone, in order to search for. So double check you've done that for the previous one as well. Has line of sight of object to our player. And again, if that's the case, we can set the state now to walk towards. You call this whatever you want. There's probably a better name you could do that, so it keeps the smaller sort of search terms that we've got before. I might just shorten this down to walk. That seems quite nice. It's single words for everything. Again, we're going to add our else, and this time is going to be searching for the player. So we're just going to add a condition to our bat, and this time we're looking for the search player timer, and we're just going to check if that is running. And if it is, then we'll set the state to search for player, or search is absolutely fine, keeping our one word. And we're coming near the end now. Now, this next one is, does it need to wander home? Now, this one's a bit more tricky because there isn't just a quick action that we can choose like we did for all the others. Instead, what we're going to have to do is go to System, compare two variables, and we want the absolute value, and then we're going to write distance, and then this allows us to get the distance between 2 points. Now, the absolute value means that if it's a negative, it will turn into a positive. So you're always dealing with a positive number. So that's really, really useful. But the two things we want to check is we want to take the bat's X position, the bat's Y position, and then we want to take bat start X and bat.start Y. And we just want to check the distance between that. And we're going to check if it's greater than a certain amount. So I'm going to check if it's greater than, and say 300. And just close my second bracket. There we go. So if it's greater than 300, it's too far away from home. So what we're going to do is we're going to set the state to home. So it's now moving back to where it started. And then our final else. And this time, because we've already covered all of our different options, we're just going to set the state to wander. We don't need to put anything else in play. We can just say that the state now equals wander. Now, there's one issue with all of this code. While most of this will check for each bat individually, certain stuff like this bit of code will just pick the first bat it comes across. So this bit doesn't work. Now, the annoying way to fix this is we're going to add a new event, system, and we just need to get this code called for each, and we need to apply this to each bat. Again, most of the time it's doing this for us automatically, but for certain lines of code it isn't. So we're going to move this to the very top. I'm going to hold Shift and click this huge block of code here, and then just put this underneath like so. If you've done this correctly, you should be able to hide everything under for each bat. And now we've got our state machine set up. These are all of our different states that will be checked every single tick of the game to make sure the bat's doing the correct thing. Now we have our state machine set up. We're actually going to do some quality of life things really quickly before we move on. And our quality of life is to do with two properties that we have, or two behaviors: our line of sight player and our attack range. Now, I'm going to set my attack range just to be 100, but I actually don't know what that means. I've got a rough idea what 100 pixels may look like, but it's really hard to visualize, especially when you're testing your game. So I actually want to make my own visualizers that I can view inside the game. Now for this, I've had a bit of trouble with this, so you'll see some stuff added, but I've actually just added a hitbox layer and a background layer. Background layer, I've just moved my background to, and my hitbox layer is currently empty. So sorry that's not being cut from the video, that's just a mistake from me playing around and getting stuff working. But the main thing that we want to do now is actually add in these two ranges. So I'm going to insert a new object, I'm going to create a sprite, and the first one we're going to do is just a player detector. And this is going to detect if the player is in a certain range. And for this, I'm just going to take a circle. I'm going to pick any color I want. Now, for the in range for the player, I'm actually going to pick yellow because I want red for attack, because that makes more sense to me. And I'm actually just going to set this to be a border only. Now, you can set this to be filled. It's entirely up to you. You can play around with this and get it feeling the way you want. But remember, this can be hidden from the actual game. This is just for testing. So make a circle. Doesn't matter what the size is, because what I'm going to do is crop this and just resize this to be 100 by 100. 100 by 100 is quite a nice value to work with. We are going to obviously change this in the editor once the game's running to match whatever the range is of that particular enemy. Most important thing then we need to do is just make sure this is center. So the reason I picked 100 by 100 is I can then write 50-50. It just makes life much easier. So once I've got that, that's going to be at the top of my screen. I can then clone my player detector and I can just rename it to attack range, and this is going to be for my attacks. Again, I'm just going to put an instance of it on the screen just to start with, and then I'm going to just edit the animation, and for this one I'm going to pick red just so I can see the differences between the two. And that's it. Those two are set up. Let's work on the code to put these in. So I'm going to add a new event, and there's going to be a system, and it's going to be just an on start of layout. So on start of layout, and just like we did before, we want to apply this to every single bat. So I'm going to go back to system and just type in for each, and we'll do this for each bat. So every bat will have its own attack range, every bat will have its own play detector. Now I'm going to add my action, and I just want to take my bat, and we're just going to scroll down to spawn another object. And it doesn't matter which order we do this in. I'll start with the attack range first. Layer is going to be layer 1, which is where my hitboxes are, but I actually prefer to just type in hitboxes. That way if I add more layers, it still applies, where if you type in 1 and you add layers underneath it, then that 1 moves and it doesn't work. Now I'm going to take this crit hierarchy. Now I'm going to be honest, this is a thing that I don't completely understand yet, and everybody keeps telling me to tick it instead of using the pin behavior. So I'm going to tick it for now, but I'm still trying to work out what this actually does. It doesn't break the code, but I can't see how it's fixing it. So if somebody can explain what this actually does, I'd appreciate that. But I'm just going to press done. And the more important thing I'm going to do instead is I'm going to go to bat, and I'm going to type in add child. Now this does work very similar to the pin behavior, but has some extra benefits as well, such as being able to select any attack range which is a child of that particular bat. Most importantly, we will put destroy of parent, so if the parent gets destroyed, we can get rid of that sort of marker as well. That's really good when we've got lots of enemies on screen, so we don't just end up with these random circles once the bat's been killed. And then the final thing we need to do is actually just set the range of this now. So I'm now going to go to the attack range. I'm going to set size. And for the size, we're going to take bat dot, then we're going to look for the attack range, then range, and that will get that value that we did. Now the range is actually only a radius, not a diameter, so we actually do need to times this by 2. And we'll do the same for the other side. Now once that's done, we can just copy and paste all of this and replace object. There's only one small change we'll have to do after, so change any attack range with a play detector. And that's just the size. We're no longer using the attack range. We're going to use the, this is why I need to try and work out what I called it, range. There we are, line of sight player. I hopefully cut out most of me typing in lots of random stuff until I found that, but there we go, line of sight player instead. And that's just our quality of life setup. Now you can also just drop the opacity of these. This is probably better to do on the layer itself, so I'm going to set the whole layer, let's have a look, opacity, down to 50%. And now if we run this, you can see we've just got little detectors of if I'm now in line of sight of the enemy, and the enemy will then chase me, and then if I'm in attack range, so I'll now be attacked. And this will just make your life a little bit easier when testing your code. Next, we're going to work on our state machine, and we're actually going to start working on the attack. Now, we should really disable these 3, but these 3 will never trigger because the bat's not taking any damage, so it will lose health. It can't be stunned for that reason, and its health will never be 1. So we're fine working on this, but if you ever want to work on a different part of the state machine that is below another one that would take priority, you can just right click and disable it. Again, doesn't matter because none of these should be ever triggered. So I'm going to add what is called a custom action. Now this is like a function but applies to that object only, as opposed to a function that might apply to lots of objects. So we're going to add it for the bat. We're going to give it the name of attack. And then we get a description if we want, but we can also put it in a category. So if I give it a category called state, this would now be its own little section. So if I go to add action here underneath state, and go to bat, and scroll down until we see state, and then attack. So now, if it's in attack range, it will attack. So now we can decide what attack actually means for our bat. And for this, we're going to go really, really simple. We're just going to add in a blank sub-event, and we're just going to get to find a path directed to our player. Now the way I'm going to do this, I'm going to do a system action, and I'm just going to do every X seconds. I'm going to set this to 0.1. So every 0.1 seconds, I'm going to get it to find a path to our player. And we'll just do play.x, play.y. Now I could get it to see if it's found the path in this attack code, but I'm actually just going to add an event underneath for this outside of our custom action. And the reason I'm doing this is there's going to be lots of times where we're looking for a path. So it makes sense to use the same code every single time. So on path found, we can take our bat and we can move along path. And that should be it now, following the player if it enters the attack range. Let's do a check. So I'm going to move into attack range of this bat. It should now wake up. It's now chasing me down, and it's going to try and attack me. Obviously, it's not doing anything once it attacks me, but we could set that up quite quickly. Now, you might be wondering how walking might be slightly different. How are we going to change it so if you're in walking range, it's not just going to do the exact same thing as attack? Well, I'm going to do something slightly different for this one. And when I say slightly different, I'm going to copy and paste the attack code because it's that slightly different where I can reuse most of the same code. I'm going to call it walk. We're going to put it under the category of state as well because it just keeps it all together. And instead of finding a path from player X to player Y, what we're going to do is going to change this very slightly. And instead what we're going to do is we're going to do random, and we're going to do player X minus, and I'm actually going to take in the bat's range. So bat, and then we can take in the line of sight player dot range. And then we're going to do the exact same thing again. And I'm just going to copy and paste this whole line, but this time I'm going to put plus. And all this is going to do is add just a little bit of randomness to the bat's behavior and to the bat's movement. Because what we don't want is every single bat to go directly to the player. We want that little bit of extra randomness. And I'm just going back and changing these to Y now. And this tiny bit of randomness will just, again, when we've got lots of bats on the screen, we'll add that little bit of extra character. So that's going to be the only difference with walk. And just like before, I'm going to add an action. I'm going to go to my bat, go down to our new actions that we did, and we'll put the walk one in. Obviously, we can do a check to say if the bat overlaps the player or hits the player, then it can also deal damage. It's doing more than just pathfinding, but for just the general movement, the only difference is we're going to add a little bit of extra randomness in. And what I'm going to do is try and lure this bat over to the other bat. And you can see they're sort of looking around the area, and that's not working as well as I want. So I'm just going to make some minor changes. And instead of line of sight range, let's just change this to attack range. So they're not moving as far. So it'll still be a little bit of randomness, but it's not going to be as bad. And if this doesn't work, then we'll change it even more, make it a little bit smaller. And what I'm going to do as well is just go to my bats on the side here, and I actually just want to up their range as well. So the line of sight players can set to 250. I'm going to set up to 400. So let's test this out. So you can see the ranges have increased already. That's our benefit of our quality of life change. And now if we're in the area, they'll start chasing us. And you can see it's not directly coming towards us. We have got a little bit of leeway before we get in the area. And then they'll obviously attack as well. So nice little simple change to our code, just to add in a little more fluctuation into their movements. So now I want to work on the actual stun. How can we cause the bat to get hit and knocked back by our player? Now, I don't want to implement a sword or anything like that. So all I want to do is just add in a really, really simple attack from my player that basically says, if my player presses the spacebar and the bats are in range, then cause damage. So if they're just overlapping when I hit space, that's all I'm going to do for the attack for the player, but I still need to add in the knockback for our bat. And to do so, we're actually going to implement a new object to handle our knockback. So this is just going to be a sprite, and this is going to be the knockback detector. And this is a new sort of script or idea that I came up with just for this video, because sadly the only knockback tutorials that are out there for top down is mine, and I wasn't impressed with mine, so I'm changing it. So first of all, I want to make a circle. It doesn't really matter what the size of the circle is at this stage because we're going to change it in the editor, but obviously make sure that you're in the center. And the easiest way to do that, because we're going to change it anyway in the editor, let's just make it 100, and then that means the center's 50-50. I'm then going to put this over my bat and just resize it to be about the same size as my bat. It doesn't massively matter if it's slightly bigger or smaller, but that's absolutely fine. And then I'm just going to move this to the top out the way. Now for this knockback detector, it needs just one behavior, and it's going to be the bullet behavior. And there's a couple of things that we want to change on our bullets. So the first one's the speed, and this is going to be the knockback force. I'm going to set this to about 500. Then we've got the acceleration, which we're actually going to use as the deacceleration instead. And if I set this to say 250, it's going to slow down 250 pixels. Apologies, it's my cat jumping up. It's going to slow down 250 pixels every second. So if we've set this to minus 250, over 2 seconds, our character will come to a complete stop. So it's getting knocked back for 2 seconds. Let's change this to minus 500, so it takes a second to come to a complete stop. That makes the most sense. Gravity does not matter. That only really matters if you're doing a platformer style shooter. And bounce off solids you can add on. It means it'll bounce off the rocks. Could be a fun mechanic. But we definitely want to make sure set angle is on. And we definitely want to make sure the bullet behavior is on also. So now we're going to deal with stunning the enemy and knocking them back. So for this, I'm going to add an event. Now, obviously, you'd want to change this in your actual game, but I'm just going to say if the bat is touching the player and I hit the spacebar. Again, would you realistically do this in your game? Probably not, but I'm going for just a bit of speed at this stage. So I'm going to add another condition and just keyboard on key pressed is space. But this is going to be indicating that our enemy, our bat, has been hit. So the first thing we want to do is actually go to our bat and we want to start our stun timer. So make sure you're on the stun timer tab because we've got 2 different timers running, and just start timer, and the duration is how long you want the stun to last. Now this is not the same as a knockback, this is just how long before the enemy can move again. What we're actually going to do is if the knockback goes on longer than the stun timer, we're just going to stop the knockback so the enemy's moving back straight away, so they're not out of the action for too long. I'm going to just set this for 2 seconds. Obviously play around, see what works best for your enemies. Now, because we've set the stun timer, it now means that our state machine will trigger this code. It'll be stuck here, and it won't be able to move to the attack state or the walk state until this has completely finished. So that's the benefit of our state machine. Now, even though they're stunned, we've still got some other stuff to do. So we're then going to go to our bat, and we're just going to scroll down to the pathfinding, and we're just going to disable it. Now, once they're in this state, we want to make sure that any route they're currently on is stopped. So they're not going to be moving using the pathfinding behavior because we want them to be moving using our new knockback system. So we're just going to hit stop on this. Now, coming to the knockback, and this is the bit that, again, is a little bit more confusing, but I think it works really, really well, so I quite like it. So what we're going to do is we're going to get our bat to spawn a new object. And this is going to be our knockback detector. Now, in terms of layer, we want it obviously on the same layer as our object. I'm not going to click the hierarchy this time. Again, I don't really understand it, but there you go. But now we're going to do something a little bit strange. We're going to go to the knockback detector, and we're going to get it to add a child of the bat. So the bat's now going to be the child. The main reason we're doing this is the parent is the one that controls the X and Y position and the angle. And we want our knockback detector to be the one that's moving, not the enemy. That sounds very, very strange, but the main reason for this is to do the angle. If we set the angle of the bat goes upside down and does lots of weird stuff. However, if we set the angle of this object and just get the bat to copy its X and Y, we'll get something that looks a bit more natural for the type of game we're making. Now, because we've spawned this object and it's got the bullet behavior, it's going to start moving, but we want to choose where it's moving. So we're going to go back to our knockback detector, and we're going to set angle. Now, this needs to be done with the set angle and not set angle of motion that's on the bullet behavior, so just the one at the top here. So for this, we're going to use the angle function. Now, the angle function basically takes 2 points, an X and a Y, and then another X and Y, and tells you the angle between the two. So we're going to take in the player's X position, the player's Y position, commas separating each one, and then we're going to also take in the bat's X and the bat's Y. And we just want to get the angle between the two. And I've just missed player.y. And that's what we're going to use to set the angle. Now that's it for the knockback, but the problem is we need a way to stop this knockback, because what will happen once it gets to 0, it'll go into minus numbers and it'll go backwards. So we don't want that to happen. So all we're going to do is we're just going to take our knockback detector. We're going to compare speed. And we're just going to see if it is less than or equal to 0. And if it is, we're just going to take it and destroy it. Now, the other reason we might want to stop knockback is not because the bullet speed has reached 0, but because the bat's stun timer has finished. So we're just going to go to our bat, and we're going to go on timer. Now there's 2 timers, remember, so we don't want the search for player, we want the stun timer. So on that timer finished. Now we also want this to destroy the knockback detector, but if we just put destroy here, we're going to have the issue where it's going to destroy all of them. We only want to destroy the one that belongs to the bat. So we're going to actually add a blank sub event, and we want to do this as a blank sub event because if we did it as another condition and it was already destroyed, then this condition will never trigger. So we're just going to go to our bat, and this is where parent and children come in really handy. We can say pick your parent. Pick the knockback detector that we have assigned you, essentially, the one that belongs to you, and then destroy that one. So I'm just going to copy this line of code and destroy it. And that should be it. That should be our knockback setup. So let's do a test because there's a lot of code we've just added, so we definitely want to make sure it works before we continue. So I'm going to move into the bat's range, and once I hit space and it's overlapping, it's going to get knocked back. Now you can see the bat does this weird thing where it goes upside down still. Now this can be for 2 different reasons. The first one is when you've set it as a child, we've not unticked the angle, which is what I forgot to do, so I'm going to untick it, but that's fine. The other reason might be on the back code, you've still got rotate object for pathfinding. It's more likely to be this one. But now when we walk up to our bat, I'm going to approach it from a slightly different angle this time. When I hit spacebar and I'm overlapping it, it will get knocked out, it will get stunned for a bit, and then you'll notice after 2 seconds, it will start moving again, it will start moving towards the player, I can knock it out again, and again it's not going to do anything. 2 seconds pass, it's now moving back towards me. So we've now got a system in place to stun the player. Now before we continue, what's really good to do at this point is just take some time to tidy up your code, either using comments or by using groups. So I'm just going to time lapse this really quickly. And there we go, that's everything in groups. And what I've done is actually just ordered these in the same order as the state machine, because it just means it's much easier to find anything that I'm after. And again, you could move this to a different event sheet. Now, let's tackle def really quickly, because the def side is really easy for us to implement. So we're just going to add in a new group. Let's stick to that while we're doing it. So we're just going to type in def, move that to the top. And this one's really easy. We could just destroy the bat right up here, but in case you want to add more stuff to it and then keep obviously your state machine quite quiet and quite small, we can do what we've done before and just add a new custom action. We're going to add it to our bats. We're going to call it def, and we're going to turn it into a state as well. And all we're going to do at the moment is type destroy. But again, what you could also do is add in an animation. You can change the color, so you can do lots of other stuff as well when the bat dies. So that's why I quite like it as its own separate action. So if this was 10 lines of code, it's 10 lines of code somewhere else as opposed to 10 lines of code in your state machine. Your state machine only takes up 2. At this stage, you're wondering as well why we do set the state, even though we don't actually need it. We could get rid of this state because we've not actually used it yet. 2 reasons. One, it just neatens things up so we can quickly read that's def, stun, retreat, attack, warp. But you can also add in extra actions later down the line and go, if my bat is in this particular state, when I do this, then apply this code. So it's just little checks that you can do. So it just adds an extra variable that you can just say, what state is my bat currently in, and does that affect what I'm doing right now? So we've now got def implemented. Now I've just realized with our stun, there's one more action that we've got to do, which is actually take health of our enemy. Because if we take health of our enemy, we can then trigger our retreat action. So that'd be really, really helpful. So I'm just going to go back to my stun, and this one's just really easy. I'm just going to add an action, bat, and we're just going to subtract 1 from health. So subtract from health by 1. And I like putting this my second action because it's quite an important one, but it doesn't really matter the order of your actions. It's just down to preference. So we've got stun working, we've got death working, attack and walk. I'm actually going to leave retreat till right near the end, mainly because I'm still working out the best way to approach that. Next, let's work on the search mechanic. Now, for search mechanic, we do need a brand new instance variable. So this is going to be called lost sites. And it's going to be a boolean. I'm going to set the default to true. Now, we also need to add in something new into our state machine. So we're going to go to where walk is and just add an else. And with this else, we're also going to add another condition to this. And we're just going to go to our bat and just go to is boolean set lost site. And we're just going to invert this. Now, once we've inverted this, before we actually add the action to this, we're going to go down to our walk code. And for our walk code, we're basically saying, is the player in range? If the player's in range, what we're going to do is add an action to our bat, scroll down, and we're going to set this lost sight to false. It hasn't lost sight, that's great. Now, the moment that we get to a stage where the bat is not dead, the bat is not stunned, the bat is not retreating, the bat is not in attack range, the bat is not in walk range, this line of code will finally get to trigger. And it will be false because we set it to false in just the state above. So what we can do now is we can take our bat, and the first thing we're going to do is we only want this to trigger once until you get back in the range of the bat. So we're going to set lost sight to true. And then more importantly, we're going to start this timer. So now this has the option to trigger as well. So we're going to take our bat and we're going to start that timer. And then we're going to start that timer. So how long is it going to take before it gives up? I set to 3 seconds. So 3 seconds of searching and then it will give up. And then finally, we just actually need an action for searching now. We've kind of done the pre-action. So I've got a new group here called search. And all I'm going to do is I'm actually going to take the walk action and copy and paste it. Just make sure it's actually in there. And there's just one small change we're going to do. We're going to, first of all, get rid of this line of code. And we're just going to rename it. And that is it for our search code. Now, obviously we want this to trigger. So we're just going to go back to our state machine and just add that action in for the bat. Again, because it's under S, it'd be right near the bottom. So we've now got this option called search. So let's give it a test. So I've got this bat on the right side. I'm going to enter its range. I'm going to stun it. If it'll let me, there we go. I'm going to leave its range. Now, once it's out of stun, it's going to continue to look for me for a couple of seconds. And then after 3 seconds, it's going to stop. So now your enemies, once you've left their range, they're not going to give up straight away. But after a couple of seconds, they will give up. They won't stop. They will stop looking for you. And then, again, that just gives you time to then go about and do whatever you want to do after that without worrying about the enemies. But, again, it just makes it a little bit more tricky for the player to escape. Now, you would have noticed that my bat got to the stage where it's quite far away from where it started. And I wanted to go back to where it started. Now, I've set this to 300 at the moment. So quite a distance away it has to be before it will retreat. But I do want it to retreat back home. So once again, I'm going to create a brand new group. So I'm just going to right click, add group, and I'm just going to do home. And this one's really, really simple. We're going to first of all add our custom action. So I actually need to right click to get our custom action up. And again, the reason we're doing custom actions for this, it just separates your code so you can add more depth to this later down the line if you wanted to. But we're going to add our bats. We're going to call it home. We're going to put it under category state. And this is just going to be another bit of pathfinding. So we could actually just take our code here and paste it below. Actually, I just want this line of code. So let's just copy that one. Now, the only issue is we don't want it to pathfind to the player. We want to pathfind to where it started. So there's one more bit of code we have to do before we can change this. And we're going to make use of the show ranges code. because what we did is we added this on start of layout for every single bat, and so we don't need to repeat that code, we'll just add it underneath. And all we're going to do is we're going to set the instance variables, which is not working when I type it, so I'm just going to scroll down, set value, there we go. I'm going to set value of start x, and we're just going to type in bat.x, and the same for the y. So we're just setting up its start positions, so now we can path find to those two positions there. So start y is now going to be bat.y. And then back to our home codes, we're going to take this really long bit of pathfinding we've just done and change it to bat.startx and bat.startY. And just like before, we're going to go back to our state machine and just add in that new action called home. So there we go, I've got all my different states. I'm going to do my one called home. And let's do another test. So first what I need to do is I need to draw a bat away from its home position. So I'm going to take this one here and I'm going to take it all the way down to here. Now remember, it will keep chasing me as long as I'm in range. So I'm going to stun it. I'm going to leave its range. It's then going to chase me for another 3 seconds, and I should have hopefully enough map. And now it'll pathfind its way back home. So it's going to make its way back home and it will remain there. So not long left now. We've got 2 more states to add. We've got the wander state and the retreat state. So let's start with the wander state. So this one is going to be a bit similar to our walk state, where we basically just want it to wander around an area, but instead of an area around the player, it's just going to be an area around where it is. And that also means there's a chance that it could wander to where the player is. Now, we could set up a global variable for this to set up a wander range, or we can set up an instance variable. We're going to set up an instance variable for this one, and I'm just going to set it to wander range. And let's set it to about 250 blocks. So 250 pixels around the starting position. That's on each direction. And this means that you could set different enemies, or even the same enemies, slightly different ranges. So if you had a big open field, you might want to make your bats roam a bit further. If you've got a small cave, you might want to only explore a small part of the cave. So you can change that dynamically for each enemy. So we're going to add a new group called wander, and we're going to add our custom action. So I actually need to right click again, add custom action to our bat, and it's going to be called wander, and category is state. And just like before, we could actually just take this line of code again. Very useful bit of code for today for getting this to work. But this time we don't want to go to startx.startY. We want to do a variation of this. So just like we did before, we're going to do random. We're going to start x minus bat dot and then wander range, hit comma, and then we're going to do the exact same thing again. So I'm just going to copy and paste this, but I'm just going to change my minus for a plus. And then more importantly is get rid of the comma at the end and swap it for a bracket. Obviously, take your time with that bit of code because it's really easy to get wrong. When you do this a few times, you start getting into the hang of writing this. But we're just going to change the start x to start y now for both sides. And now we've got our wander code set up. Most important thing we need to do is obviously tell it to do this bit of code if it reaches that state. So I'm just going to do bat, scroll down to the bottom, and get it to wander. So now we've got the wander code set up as well. So let's see how this looks. So unfortunately we reach a very frustrating part of the video where for some reason the right bat will not wander. The rest of the code triggers, it will move, it will chase me, it's doing its knocked back. But for some reason, when it gets to the wander code, it just sits there. Can't work out why. You can see it's going to retreat and go back home to its start position, so that code's working. But for some reason, it does not want to wander or move about. And I can't understand why. And you can see if I add more bats, it is only the first one that ever decides to wander. Despite the code being set up the same for every single function, only the first one wants to wander for some particular reason. I've checked the frame rate. The frame rate is actually running about 110, 120, so I don't think it's a frame rate issue. I've tried changing it as well, so it actually only does the state machine updates every 0.1 seconds in line with the pathfinding, and that's causing issues. So I'm Not really sure, unfortunately. So if you've got an answer for this, please let me know. I'll have a play around before I send this video out, but I want to get it edited soon. So I'm going to unfortunately leave it in this state and work on the retreat code. But yeah, very frustrating, very annoying from both our ends, so I apologise for that. And for the retreat, we're just going to do something really, really simple for this. We're going to just take in our Wonder code and copy and paste it. I'm then just going to move it to the side and rename this retreat. And instead of taking the bat start X position, we're just going to take its X position. What this will do is this will just generate a random position nearby that it can go to that should be hopefully away from the player. It's not going to be perfect, but trying to get it perfect actually is a lot of calculations that can get really, really laggy because you've got to take into account which way the player's facing. You've got to do calculations based on that to then generate an angle for the bat to move to. And that could slow down your game quite a lot. So there are ways to do it, and there are ways to do it efficiently, but it is a lot more complex. So we'll just get it to find a random place in quite a large area and move to that and run away. So that's near enough all our code done. Obviously, the Wonder code not working properly is very frustrating, so I'll look at getting that fixed. But there's one more thing I want to show you with all of this, and why this bat code here, this AI, can be actually really, really useful and really, really big for your game. Because if you're thinking about just this is a lot of code for one enemy, you're right. However, what we can do is we can do something very, very clever. We're going to clone our bat. I'm going to call it bat2. And for bat2, I'm going to edit its behaviors. And I'm going to delete all of them. I'm then going to take bat2. I'm going to take all its instance variables. And I'm going to delete all of them. I'm then going to create a new family. And I'm just going to add bat2 to begin with to our new family. I'm going to call it enemies. And now the really annoying thing, and I wish Construct had a better way to do this, is we're going to add back all of the behaviors that our bat had. And this also means renaming any behaviors that we renamed. And also means adding any instance variable our bat had. But if you could be bothered to do all of that, you can first come down to your custom actions at the bottom. You have to do these first. And you can replace any mention of bat with enemies. You can then also do the same, and you can replace any mention of bat now with enemies. And you now have codes up for every single possible enemy you could ever want in your game. Now, you can't use bat, you'd have to use bat2 now from now on, just because of the way that families are created. But you can also do something really, really interesting with families and custom actions. Let's go to our attack action. And what we're going to do is going to right click, and we're just going to add a new custom action. And it's going to be to bat2, and I'm going to call it attack. Now we already have an action called attack, which means it's going to override what it means to attack. It will always use this version. If the bat's doing it, if any other enemy does it, it will use this version of the attack. So what we could do is we could actually get it to spawn another object. And this is not going to be set up properly because I'm doing this very quickly at this point. But we could spawn another object, and we could say spawn a projectile. We could get it to spawn a rock and throw it at our player. So now what the bat thinks attack means is once it is in that attack range, it's going to throw rocks at the player. But what every other enemy thinks the attack means is to get close to the player, so you actually cause a physical attack. And you could do this for any of the actions. You could say actually what it means to retreat if you are a big giant is that you don't retreat. We override it so it doesn't retreat, it just does an attack. What you could do though is have it so a stun is different for different types of enemies, and all you do is just create a new action, give it the same name, and it overrides it. So as always, this code will be available. I'll make 2 versions of this code available. I'll do one as the bat code, I'll do one as the family code, so you can decide which one you want to use. I'll also see if I can get the wonder working before I put this on Patreon, but I want to start editing this now because we're already a month behind our last video. But thank you for all your support. Thank you for sticking with me during this Patreon, and I'll see you in the next video.